Welcome next session. So in this session, we will be discussing another one of the very important concept called as the inference engine. So what actually an inference engine? So an inference engine, we can say that it is a very important component of an intelligent system. Right? It's a very important component of any intelligent system in an artificial intelligence. So here now we try to apply some of the logical rules to the knowledge base so that you are going to infer some new information. So we already have some facts. So we are having certain facts in our knowledge base. Now we apply our inference engine to this particular knowledge base so that we are going to get some new facts. So we'll get new facts. So by this particular new facts, again now we can try to prove something or try to conclude something, or in general we are saying inferring something. So this is what the inference engine says that. So every human being, or we can say our brain also has got certain inference engine. So whatever the facts we are having, then we try to apply some logical rules so that we can try to infer something. Generally this inference engine, it was a very important, or it is a very important component in any expert system, right? So what is an expert system? We'll be discussing it later. So when you consider an expert system, the inference engine plays a very important part. Now this particular inference engine, there are two ways or two modes we can build an inference engine. So one is called as the forward chaining, or it's also called as forward reasoning, or the second one is called as the backward chaining or backward reasoning. Now I can see here, as you can see here, whenever we human beings we are going to consider, now we have some knowledge base with us, right? So we have certain knowledge or collection of various facts. Then we try to apply the inference engine so that from this knowledge base you can extract certain new information or new facts, again store it back into the knowledge base. It is like an iterative process. You keep on doing until you are able to conclude something, and whatever you try to conclude, now you will try to give it to as an output to the other end. So this is what basically an inference engine talks about. So now we have two types, as we told. So one is forward chaining or forward reasoning. The other one is called as the backward chaining or backward reasoning. So if you consider the forward chaining, what do you mean by the forward chaining? Now it is, as we are told, so it is one of the important, or one of the important method in which you are doing the reasoning or you are doing the inference. So now here we try to apply one of the inference rule, which is called as modus ponens rule. So this is one of the rules which you have already studied in your previous semester. What it says that if a particular fact A is there and you have got A implies B, from this you can conclude B. So you can conclude B. So which is nothing but our modus ponens rule. You try to apply this particular rule. And forward chaining is very popular implementation, as we told, in expert system, in business, or you can say our production rule system also. And when we are talking about the backward chaining, it is nothing but just opposite to that. So this forward chaining, always it starts with the available data or facts, or what we are going to call it as the known facts. Whatever the data right now you are having, you start with that and uses the inference rule. So which is that particular inference rule we are following? We are following the modus ponens. This is the inference rule which you are going to follow to extract more data, or we are going to tell extract new information until a goal is reached. So until you have reached the goal or you have proved a particular statement. And this inference engine here, it uses forward chaining search. So as we told, so that is, it keeps on searching by applying the inference rule until if one of its antecedent or if class. Now we know that whenever you are writing some if statement, so you are going to say, for example, if A then B or implies B. So the left hand side is called as the antecedent, and the right hand side, so what you are going to get afterwards, it is called as the consequent, right? So now here what we do, first you try to compare, find whether the antecedent is matching. That means if this particular A is matching with any of your facts, known facts or data in your knowledge base. Suppose say that in knowledge base already you have got fact called as A. Now this A and this inference rule, now this matches, so you are going to conclude B. So now with these two, that is this is with this and with this particular A implies B, now you are going to conclude a new fact which is B by applying the inference rule. So that's what we say, that you keep on applying this until the antecedent, that is if class is known to be true, if it matches. Now when such a rule is found, the engine concludes or infers the consequent. It concludes if A and A matches, you are going to infer or you are going to conclude B. That is what we say consequent, resulting in the addition of a new information. Now this B is our new information in our knowledge base. So this is how this particular inference method is going to work. So a few other points which has been given, the same points are being given here. Now what it says, so this forward chaining, it's also called as forward deduction or forward reasoning. So these are different terms which is being used. It is a one type of a reasoning, one form of a reasoning now which starts with an atomic sentences, or a simple atomic sentences means a very simple sentences which does not has any implication. Very simple statement from the knowledge base, and we apply the inference rule, that is modus ponens, in the forward direction until you get a new knowledge or your goal is reached. And this is a bottom up approach. We call this as a bottom up approach as it moves from bottom to the top, and it is a process of making a conclusion based on known fact, right? Already we discussed. So now when we look this particular the mechanism what we are following in our inference engine. So when you are talking about the inference engine, we have two. One is forward chaining or forward reasoning, similarly backward chaining or backward reasoning. So now here this algorithm, as we later will see the algorithm how in a very brief manner, how it starts from the known facts. So we are having some facts with us, so we are going to start with some of the facts, then we apply the rules. Now there are certain rules also there in our knowledge base. Now these rules are being triggered or apply that particular rules such that you get the consequence of that particular rule. So you are going to apply those things. So we take the initial facts, so then we try to apply the rules. The rules have been triggered by giving us a new knowledge, and we keep on repeat, and whatever the new knowledge comes, again we add it into our database until we get our conclusion. Now let us take an example and we'll try to understand how this method is going to work. Now let us take this particular diagram, or you can say this particular example. Let us try to consider. Now what does the problem says that, now does Z satisfies or exist? Now you want to prove Z, so you are supposed to prove Z, whether this Z is true or not, whether it exists or not. So now to do that, now we are given some facts. So say that this is our knowledge base, so on the top whatever is there, so in this diagram we can consider this as a knowledge base, and this square bracket whatever is there, now these are the rules. Now all these are present actually in our knowledge base. So now if you consider here, so we have some facts, we can say A, B, C and E. So now what we do is, now we try to compare this with our rules, whatever rules we are having. Now say for example, if we take the first rule says F and B implies Z. Now F, does F exist in our knowledge base? F is not there in our knowledge base, so you cannot, or this rule is not triggered, or you cannot apply. The second rule, if we consider C and D, C is present in our knowledge base. You can see C is already there, but what about D? D is not there in our knowledge base. We don't know about D. So this second rules also we cannot apply. So the third one, when you consider the third rule, now you have got A and A. So now A matches with A. So that means you can apply this rule. So this particular rule is triggered. So we can say that now this rule is triggered. Now you are going to match the antecedent of the rule, if rule, right? This A and A matches, so implies D. That means you are going to conclude D. So you conclude D. So you got a new knowledge D. So the first rule fires, that is A implies D, because A is already in our database. So next we infer D. So this D is our new knowledge which we got. This is added into our knowledge base. So now D is also present in our knowledge base. Now previously D was not there. How D came? Because this third rule was triggered with our inference engine. So now D is a new knowledge in our knowledge base. Now again we start repeating the same process. Now you will take the first rule, you try to compare. F is not present, so you cannot apply the first rule. When you take the second rule, C, yes, C is there. What about D? D is also there. So C and D implies F. That means that you can conclude F as a new knowledge, add it into your knowledge base. In the next iteration, now F is also added to your knowledge base. Right? Now, and what about A? A is already matching. This rules also triggers. This also triggers. Now, when you look here, A implies D. Already D is present, so we need not worry about this rule. So in the next iteration, in the third iteration, now we see F. We compare. F is present in our knowledge base. Yes, F is there. What about B? B is also there. F and B implies Z. So now we got a new, or we inferred a new knowledge Z. So Z is added into our knowledge base. So we got Z into our knowledge base. So now what was the problem statement it is telling? Does Z exist, or are you able to prove Z? Yes, we are able to prove Z from the given facts. This is what we call the forward chaining or forward reasoning. Right? So I think this is very clear. Now if you look into the algorithm in a simple way, based on this particular diagram, if you look in the same way, you can write the algorithm. What it says, given m facts, now we are having some facts and n rules. So we have got some rules. So we have some facts here, A, B, C, E, and we will be having certain rules here. Then we keep on repeating. What we try to do, if one or more current fact matches with the antecedent of Ri, you take any rule. If any one facts, like say A matches with A, if these two matches, this rule is been triggered. So once this rule is been applied or triggered, you get a new knowledge D. So add that new knowledge D, a new fact defined by the consequent. So this is consequent, right hand side. This is incident, that is the left hand side. And flag that rule that has been fired. You can just say which rule has been fired, and increase m until no new facts has been produced. Now you keep on repeating these things. So this is the, in a very simple, we can try to write the algorithm, or else even we can try to implement this, or even in another way you can even understand the algorithm in this method also. So what it says, collect the rules whose condition match the facts in our working memory. So we have some rules. So now what we do, if more than one rule matches, so if you keep on matching, if there is a conflict, you can resolve the conflict. So sometimes what happens in knowledge base, there might be more than one rules might match. At that time you have to have a conflict resolution. There's another strategy through which you can remove the confusion, and you keep on applying this rule and add that new facts to your working memory, and you repeat until a goal is found. So either in this way or in this way, you can try to write the algorithm, generalized algorithm for the forward chaining or forward reasoning. Now this is another example with a pictorial form which is been shown. Now it is similar to the previous example. We have our knowledge base with certain rules, and also we have our database where we can say some simple axioms are been present here. So now from this particular knowledge base, now you are going to see that what facts can be inferred, what all the new facts can be inferred. Right? So now what we do is, so we start with this particular thing and we start looking into our rules. Right? So now you are going to see A is there in our database. Now you are going to check A is already present here in our database. Now in our rule you can see A is there. So A and A matches. So now this rule is been triggered. So you get a new knowledge X. X is added into your knowledge base. So you can see here X has been added. Similarly C is there. Now you have a rule which says C implies L. So C matches. So this rule is triggered. L is added into our knowledge base. Now if you take any other rule, like say if you take Y is not present here, so you cannot, this rule is not triggered. Now what about this rule B is there, E is there, but what about X? AND is there here, AND operation is there. So this also cannot be applied, this also cannot be applied, this also we cannot apply. So this, in the first iteration we got new facts like say X and L is been added. Next, again you keep on repeating the following steps. So until what all the new knowledges, at the end we can see that apart from A, B, C, D, E, now we got X, L, Y and Z as the new information what you are collected. So this is another example, so through which you can try to understand. The same thing is given here in the theory. Now let us take another practical example and we will try to see how the forward chaining rule can be applied. Now what does the example says? Now as per the law, it is a crime for an American to sell weapons to hostile nation. Now country A, an enemy of America, has some missiles and all the missiles were sold to it by Robert, who is an American citizen. Now prove that Robert is criminal. So we have certain facts. Now with this, what we have to prove? So whether Robert is criminal or not, we have to prove by using our forward chaining or by our inference mechanism. Okay, so this is a very simple example, the real-time application we are going to consider here. So what we are supposed to prove? We have to prove that Robert is criminal. So the first step, what you are supposed to do, we have to convert the above facts into the first order classes. So we have to convert it into first order propositional logic or FOPL. So we have to write this entire things. This is the entire knowledge what we are having. So now we can try to consider some of the variables as far as the given problem. Now say for example, now we will try to understand the first line. Now what are the first line says that as per the law, it is a crime for an American to sell weapons to hostile nation. So we will consider our first statement here. So what it tells, it is a crime for an American, right? So we will take first, we will try to write down the first rule. Okay, select the pen. Okay. So what we will try to write our first rule. Now what it says, American, right? So we are going to use American. We will take any variable, let us say P. So P is an American and sells weapons. So we need a predicate for a weapon. So we will write weapon. We will use a variable, let us say Q is a weapon. Sells a weapon to hostile nation. So hostile nation is another predicate we will define, and hostile, let us say R. So now we have got an American weapon and a hostile is the predicate what we have done, and here it tells that it is crime for an American to sell weapon. So sell is again, and we'll say sell is one of the predicate. Now who is going to sell what? So the arguments you have to clearly write. So American for an American, so he is going to sell weapon to hostile nation. So we can say that P, so P means what? An American sells Q, so Q is what? A weapon, and R to a hostile nation, right? Implies, now what does this implies? So if an American, or it's a crime, see here what it is given, it is a crime if you are going to sell a weapon to any other hostile nation. So implies, so what it implies? It implies criminal. We will take as one of the predicates. So now who will be the criminal? This particular person will be the criminal. This American will be the criminal. So inside we will take the variable P. So this is the first statement we have converted into our FOPL. Now let us try to look into the second statement. Now second statement says that now country A, an enemy of America, has some missiles. Right? Now we will try to look into all these things. So country A has some missiles. Right? So now this is country A has some missiles. Now we will try to convert this into the FOPL. So now what we can try to write here is that now there exist, let us take a variable called as X. Suppose if A is a country, right? Now there exists X has some. So you can see this word some is coming. Some means there exists. So there exists X owns, we will write one predicate. Now who is owning? So A is a country. So a country owns some missiles, right? So country A owns some missiles. Now what this X indicates? X is some, right? There exists, we are telling. So and what is this X? X is missiles. So we can say X is the missile. So now this is our, let us say, the second FOPL, or we have converted the extracted the fact and we have written. Now it can also be written with respect to the two definite classes. Now we are going to use this particular statement or the fact what we have converted. Now we know that here we have defined these two predicates here. So we can try to divide it. The third fact I can take about this. What is this? So I can write it as owns is one predicate. Now a country owns some missiles at T1. I'll write it as a variable. So I'll take it as the third class, and the fourth one is the missile. So we can write missiles which is T1. We have just splitted this into two things. The same whatever the predicates we are having. So next if you look into the problem statements. So now all missiles. Now you can see here the next statement what it says. All the missiles were sold to it by a person called as Robot, who is an American citizen. Right? Now if you consider this, all of the missiles were sold to country A by Robot. Right? This is what it says. So now all of the missiles now you observe here has some missiles. See right here it is telling has some missiles, and those all these missiles were sold. So we will write there exists P where you can say P is quantified with the predicate missiles, and if it is own A comma P, right, this particular country owns these some missiles. Now what it indicates? Sells. Who is going to sell? Robot is going to sell what? These missiles owned by one particular country. So all the missiles were sold to country A. It was been that is by Robot. So Robot is selling all the missiles to the country A. So this is the next you can take the class. Now still, now you consider here missiles are weapons, right? Somewhere you can see this, these missiles are nothing but a weapons, because here we are telling that sells weapons to hostile nation. So when you are selling in weapons, so obviously these weapons are nothing but the missiles. So now we can try to say that all missiles are weapons. So now this, it can be converted, we can write it as missiles, that is P. If you take a variable P, if P is a missile, implies that it is an weapon. P is a weapon. Next, if you further look into our, that is the information whatever we are having. Now we can say that enemy of American is known as hostile. So this is also information we can extract from our particular problem, right? Because obviously whoever is selling the weapons, he becomes an hostile to a hostile country. So the American itself is selling, right? If he sells that weapon to an hostile country, obviously he becomes the enemy of that particular country. So now it is also the information which is present in our given problem. So we will write this. So we will take an predicate called as enemy, enemy. If P is an enemy of America, then P is a hostile country. Then P is a hostile country. Now the last one. Now we have got the country A is an enemy of America, right? See, country A is an enemy of America. So this is also the fact which you can observe from our problem statement. So now this can be written. We'll take the predicate as enemy, now A comma America. And the last one is we have what we want to prove. So Robert is an now is also an American, right? So now we'll write that. So we'll take the predicate American. Now is that Robert? So he is also an American. Now these are all the various information from our problem statement. We have converted it into our first order predicate logic. So now this we can say all these are the rules. The same thing has been written. So now totally you have taken 8 rules here. This was the first one we wrote, P of America and weapons. So P says that weapons and a hostile nation implies that he is a criminal, and a country A owns a missile T1. The T1 is a missile, and we have written all the missiles were sold to a country A by Robot, and missiles are the weapons. Enemy of America is known as the hostile country. Then country A is an enemy of America and Robert is an American. So we have converted all these things into the first order predicate logic. Now this is what we are going to consider, that this is nothing but our knowledge base. Now we can say this is the entire knowledge base which has got some simple atomic statements. simple statements without any implication. So which are all the simple statements here? Now if you observe in this, so the second one is a very simple statement because you don't have any implication. The third one is a simple statement, seventh is a simple statement, and eighth are the simple statement. Now we will try to apply our forward chaining or forward reasoning and try to see that whether robot is an what we want to prove. So first step. Now what you are going to do in the first step. Now we start with the known facts. Now what are the known facts to us? So we are going to start with all our known facts and we'll choose these sentences which does not has the implication. So now what are the, as we told, these simple statements now we are going to consider. So these four statements what I have marked here. So that is this is your second statement, right here. Then this is your third one, seventh, and the last eighth one. So we have just selected all the simple statement. This we can say simple facts. Now in the second step, now we try to check these facts. From these facts, can we infer anything by using MP rule, modus ponens rule? Now you can think that these are all like A, right? This can be, imagine this is A. Now you have to look into the sum of the, you have to apply the modus ponens rule. So now in the remaining classes, you look into the rules or inference rules which is of the form, say for example, you have got something called as P implies Q. Assume that this entire thing is P, this implies Q. Now you have got a fact A. You have to compare A left side. So A and P does not matches, so this rule cannot trigger. Now similarly you might be having another rule. Now another rule, it might be A implies B. Now A and A matches, so you can apply this rule. The same diagram previously what you have seen as an example. The same thing we are going to do it now in our second step. So what we try to do is that you look into the facts, that is the basic facts what you have considered. Now let us try to see here. Now what we are having. So we started with these four things. So now we will look into our what are the rules we are having. So if you take the first one, America in bracket robot, already it is present. Now you see any other rules which is matching with this particular American. So American only here, for no other things we are having the American is not there. So you just neglect that particular thing. Go to the second one. Now what is the second one is you are having missile, right? So you have got missile is there, missile of T1. Now you check missile, does it matches with any of your rules? Now you have to check only the rules. That is this the first one is the rule because you have got an implication here. The fourth one is a rule, fifth one is a rule, sixth one is a rule. Remaining four is these statements what you have considered. Now if you take missile, now you can see here when you look into the fifth rule, now you have got missile of P implies weapon of P. Now here missile of T1, don't worry about this variable T1, right? If you can unify this T1 with respect to replace it with P, then this missile and missile matches with each other. So you are going to apply the modus ponens rule, A and A implies B. So A implies B is missile of P implies weapon of P. Right, and this is missile. A matches, so what you can infer, therefore you can going to infer B. So what is B? B is this one, weapon of P. So now this becomes our new knowledge. So now this, from this missile, so you are going to infer this one, that is weapon of T. Now similarly, if you consider this missile, the first statement, okay. So if you look here, the first one, the fourth one. Now you can see here the fourth one. The fourth rule, you just consider the fourth rule. Now what is present in your fourth rule? So fourth rule says missile, right? So already missile is there. missile which we are trying to consider. And what about the owns? Owns is also present here. So now these two matches, and is there, so both matches, so it implies this one. So robot cells P comma A. So now that will be your new rule which you are going to add it here. So from these two, so you are going to add this particular rule you are going to add. Clear? Now similarly you take the next one, enemy A comma America. Now this enemy 7th one if you take, now it matches with the 6th one. Enemy matches. So what is the new role you are going to consider? Now hostile. So this is one which the new fact which comes into our knowledge base. And from the missile weapon is also we have got cell and hostile. Now this entire thing is the new knowledge base you are having. This is clear? So you are applying some rule. You just match the LHS left hand side. Now you got these things. Now iteratively we try to keep on moving to the next step. So now when you in the same basis, now when you move into the next step, now compare what are the rules are again present with us. So now try to see that are you able to do it. So now already this 4 was there in the first iteration, these 3 added with us. So now when you consider at this third step, now if you look into the first rule what you are having, so say America P is an American. Now you check in a knowledge base whether it is there. Yes, American is there, but here robot is there, your P is there. Now you are going to replace P by robot. You are going to unify that. So if you unify that, so this particular thing, first one matches, right? Next is weapon. Now you see weapon is there in our knowledge base. Yes, weapon of T1 is there, but here Q is there. You have to just unify, replace T1 with Q. So if you replace, so now this also matches. Now consider the third one. So what is the third one? Let me bring this here. Okay. So now what is the third one? Cells P, comma Q, comma R. Now you check, we have already there, cells is there. Robot T1 and A. Now already robot you are replaced with P. So since you are replaced in the previous step, robot is already replaced with P. So now this becomes P already, right? So P is replaced with the robot. So now here, so in place of P you are going to have robot. Now what about Q? Now Q is replaced by T1, right? So now if you replace that with T1, so this also matches. So next one is your T1. So R. So now R, here A is there, so replace R with A. So when you unify this, so now this becomes A. So now it becomes cells. Now this and this matches, right? So now 3 things are already matched. The next one is hostile. Hostile of R. Now you can see here already hostile is there and R is replaced with A. So obviously, so now this becomes A. So this is your A. So all the 4 matches now. For all these things we have got. Since all the 4 matches, apply your MP rule, modus pennon rule. Now what that particular rule says, you look into the consequence. So implies that what it says, criminal of P, right? So now this thing is been coming into our knowledge base. So now this particular thing comes into our knowledge base. So now when the new knowledge, when you are adding into your knowledge base, so what it is telling, criminal. What is P? P is already replaced with robot. Now this is what you have proved. So that robot is a criminal. Now what you were supposed to prove, so when you look into your problem statement, now what it is telling that with the given knowledge, right? So this particular statement, it is saying prove that robot is a criminal. And with the help of our forward reasoning, so now we came to a conclusion, or what we have proved, the new knowledge which came into my knowledge basis, robot is a criminal. So hence the proof. So this is what the forward chaining rule, or we can say one of the inference mechanism, of the important mechanism. So in this session we have just understood what you mean by forward chaining. So in the next topic we'll be discussing the backward chaining or backward reasoning. So backward reasoning is nothing but it is a reverse process of the forward chaining or forward reasoning. Okay, try to practice these simple examples so that it will be more clear for us when you go for the backward reasoning. Thank you.